Hi, I'm a Donnie the Physics guy here with another talk. Today we're gonna start a conversation about wave particle duality. Okay, this sounds something that nobody wants to hear about, okay? Especially since it's been debated for over 100 years, okay? So this sort of led into quantum mechanics. So the problem physicists had back around 1920 was that uh, they could describe the the electron orbit around a nucleus. They could describe it best as a wave function. Okay, but when um, when an electron was ejected from the when an electron was ejected from the nucleus of an atom in a cloud chamber, it appeared as a particle. It made a streak through the cloud chamber instead of just coming off as electromagnetic waves. So they had this problem. On the one hand, the cloud chamber said it was a particle. On the other hand, the orbit sort of said it was a wave function. It was a wave. Okay. Now, a lot of what they don't understand about this duality is because of the Michelson-Morley experiment back in the 1890s that supposedly proved that electromagnetic waves that have all the properties of sound waves, that they have Doppler effect, constructive and destructive interference. Sound waves have the quantized energy, the phonon, and electromagnetic waves have the quantized energy, the photon. So they're identical, but because they could not see the medium in which the electromagnetic waves propagated, they decided that there was no medium, that there was just a vacuum. And modern physicists have discovered that you can't have space without structure. Space requires structure, and then there are a lot of uses to having a medium. Now, I define this medium to be a gaseous particle. And we don't know exactly how small this gaseous particle is. It could be of Planck length, okay, or tinier, or it could be, what did I say, a quintillion times less massive than the electron, okay? So, I postulated and defined this particle. I defined this particle as the God particle 1, GP1, as the tiniest particle of mass in the universe. Okay, and then once you proceed as if, okay, now if you proceed as if electromagnetic waves propagate in a medium of GP1s, God particle 1s, the tiniest particle of mass in the universe, a gaseous particle. Okay, this particle is defined as very resilient. Okay, so it can be compressed to a lower volume under pressure, just like we can compress hydrogen or propane into a tank. Okay, This particle can be compressed into a lower volume, and as part of that compression into a lower volume, heat is released. So as you compress a GP1 into a lower volume, you release heat. Okay. Energy. Energy has to be extracted to compress it. Okay. And then energy has to be absorbed during the decompression. Okay. So, okay, now you don't have to believe in the GP1. You can believe that space is empty if you want. But modern physics say space is not empty. They say it's full of these strings that come into existence and pop out, pop in and out of existence. Okay. What I say is that electrons hover. I say protons hover. I say, and when I first made this postulate back in 2019 or so, I looked up hovercraft, and the British military have a lot of hovercraft, and there are a lot of nice videos showing hovercraft if you decide to Google hovercraft. Okay, now, okay, so let's take the electron for instance. Okay, it's an indestructible particle. What that means is you can shoot it through a proton or a neutron. You can shoot it through it, and it's indestructible. Okay, and neither the proton or the neutron or the electron is seriously damaged when you shoot an electron through a nucleon. Okay, you can do that. Okay, so it's indestructible. So the other thing to know is that the proton and the neutron are also indestructible particles. Now there is a way to destroy them, and that way involves an antiparticle. So if an antiproton and a proton are close enough together, they're going to attract each other, and then they're going to annihilate each other. Now, physicists do not know why. They do know that they are attracted to each other because they have opposite charges, but they do not know how they have opposite charges. They do not know what is the mechanical difference between a proton and an antiproton. Okay, so listen up. You're going to hear it from me. Okay, so the mechanical difference is, okay, that the proton, the electron, the neutron can be viewed as a little dynamo. Okay, we're given that they have a spin. Okay, and we're given that they have magnetic poles. They have magnetic north pole and they have magnetic south pole. Okay, so since they have a spin, so it's like the Earth. Okay, the Earth has a magnetic north pole and it has a magnetic south pole. Okay, now if you look down on the north pole of a positron or a proton, it's spinning clockwise. Let me get this straight. Okay, a positron would have the same charge as a proton, and they're both spinning clockwise if you look at the North Pole. Okay, now if you look at the North Pole of an antiproton or an electron, it will be spinning counterclockwise. So the charge, you heard it here first. I've been saying it for a while. The charge of a proton or an antiproton is determined by its spin relative to its north pole. Okay? The two are mirror images of each other, but they have different charges. So my postulate is that they have different charges. Then I have a secondary postulate that the proton is a permeable sac, and that it pulsates. It pulsates and it hovers. What it pulsates are GP1s, God particle ones. I further postulate and will prove that a proton matter heats up by net compressing GP1s inside the permeable proton sac. Okay, so you put more GP1s inside, you compress them into a lower volume, and then there's more pressure inside the permeable proton sac. It pulsates faster, and that's how you get a higher frequency electromagnetic waves that harmonize. Okay, so you also now know something that no one has explained to you or well explained to you, how both matter and energy are stored inside the proton sac. The energy stored inside is in the form of compressed GP1s. So that's why a more massive particle has more energy inside its sac. And why there are more protons than antiprotons is because that's how they're made. Okay, but if you change the compression and decompression, okay, we'll pick it up later. We made a good start on this video. I'm losing my voice, so I have to see what I can do about that, and maybe I can put two videos together or not. Okay, so more, but you learned a lot today. You learned that protons are permeable sacs, and inside get compressed GP1s, that's a gaseous particle, and the medium of electromagnetic waves. Oh, and then you can learn some more too. Okay, since there's a medium, the GP1 a ether medium of electromagnetic waves, then the universe has to be finite because the medium has to be under pressure. Okay, if the universe was not finite in volume, then the GP1 gaseous GP1s would not be under pressure. It would be like going into the upper atmosphere, where the atmosphere is too thin for suns too thin for the upper atmosphere is too thin for sound waves to propagate. And so we know the universe is finite in volume, and then I grew the universe from GP1s. So the GP1s hooked up together, they made strings. The strings got woven into sacs, sort of as how single cell plants developed from phospholipids and stuff, and developed into a single cell. Well, except we're evolving to the size of the neutron. Okay, so the GP1s formed strings, got hooked up into strings. The strings got woven into sacs, and the tiniest sac that pulsates, hovers, GP1s in and out, is the electron neutrino. And then the electron neutrino, the neutrinos oscillate, and they have different masses as they come from the sun. And then eventually the neutrinos grew to the size of the electrons, and then they may have grown up to be quarks, and then the quarks evolved into nucleons. Okay, so that's a lot to take. So you got a lot, and I'll repeat it again if I post this video. So my beard is looking nice. I think I'm alert and sharp. Okay, so we'll talk more again when I get my voice back. Bye.